What measurement costs? The uncertainty principle as a description of reality, not a limitation of science. 1. What Heisenberg said. In 1927, the German physicist Werner Heisenberg published what became one of the most famous and most misunderstood results in the history of science. His uncertainty principle states that the more precisely you determine a particle's position, the less precisely you can simultaneously know its momentum, and vice versa. The more you pin down where something is, the less you can know about how it is moving. The more you know about its motion, the less you can say about its location. This result has been almost universally understood about a statement about the limits of measurement, a frustrating practical constraint imposed by the fact that any active observation disturbs the thing being observed. Shine light on an electron to locate it, and the light itself nudges the electron, altering its momentum. The uncertainty in this reading is an epistemological problem. We cannot know both quantities simultaneously because we cannot observe without interfering. This reading is not wrong as far as it goes, but it does not go far enough. What it misses is more interesting than what it captures. 2. Position and momentum are not two properties of the same thing. Position is a spatial description. It answers the question, where is this right now? It is a snapshot, a location in space at a moment frozen for measurement. To have a precise position is to be, for that instant, fully located. Momentum is a temporal description. It answers the question, how is this moving through time? It is not a snapshot, but a trajectory, a direction, and a rate of change that, by definition, requires more than one moment to be what it is. To know momentum precisely is not to know something about the particle's past and future, not merely its present location. Position and momentum are not, therefore, two different quantities that happen to be difficult to measure simultaneously. They are descriptions of two genuinely different aspects of physical reality, the spatial and the temporal, the structural and the processual, applied to the same entity at the same moment. And here's what Heisenberg's mathematics is actually saying. These two aspects of reality cannot both be fully collapsed into a single measurement simultaneously, not because our instruments are inadequate, but because the spatial and temporal aspects of a physical entity are irreducibly distinct in nature. To fully specify one is to release the other, not as a practical limitation, as a structural fact about what physical reality is. 3. Wave and particle. The same structure appears in what physics calls wave-particle duality, the experimentally confirmed fact that entities like electrons and photons behave as particles under some conditions and waves under other conditions. A particle is a location. It is the spatial anatomical aspect of the entity, discrete, bounded positions. When you detect an electron as a particle, you are detecting its where, this place, this moment, this specific location in space. A wave is a process. It is the temporal physiological aspect of the entity, extended, undulating, defined by its propagation through time. A wave is not a thing at a location. It is a pattern of change moving through the field itself. When an electron behaves as a wave, it is expressing its when, its temporal process, its distributed becoming, its existence as an event rather than as a fixed location. The particle aspect and the wave aspect are not two different objects that the electron switches between. They are the same entity's spatial and temporal natures, each fully real, each irreducibly itself, and, as Heisenberg's principle states in mathematical form, not simultaneously fully expressible in a single measurement. This is not a paradox awaiting resolution. It is the spatial temporal pairing observed at the quantum scale, showing its own irreducibility in the most precise mathematical language physics has available. 4. Maya, measure as the fulcrum. The Sanskrit word Maya is most commonly translated as illusion, the world of appearances that obscures deeper reality. But its etymological root is ma, to measure. Maya is literally the measured world, the world as it appears when it has been fixed by an act of measurement. This is not coincidental. Every act of measurement is an act of fixing, of collapsing the open processual reality of a phenomena into a single, spatially located, temporally frozen value. When you measure position, you collapse the wave into the particle. When you measure momentum, you access the wave's temporal nature and release the spatial location. Measurement does not reveal a pre-existing fixed reality. Measurement chooses which aspect of a genuinely two-sided reality to bring into focus, and in so doing, necessarily releases the other. Maya, the measured, is not the whole of what is there. It is always a selection, always a choice of which aspect to fix, which to release. The uncertainty principle is physics arriving by its own rigorous path at what the contemplative traditions were pointing toward from the other direction. The measured world is not the whole world. The act of measurement is not neutral. And the reality underlying measurement is not a collection of fixed things, but an irreducible pairing of spatial structure and temporal process, neither of which is more real than the other, both of which are always present, and neither of which can be fully grasped while the other is held completely. The instrument of measure is always a does-level tool. What it contacts is always a can-level reality, the irreducible pairing of where and when. The measure produces a three-level result: specific, irreversible, received. What it releases in the act of receiving is the other half of what was always there. What this means. 5. The uncertainty principle is not a confession of scientific failure. It is one of science's deepest structural observations that physical reality at its most fundamental level is organized as an irreducible pairing of the spatial and the temporal, the positional and the processual, and that no single act of measurement can access both simultaneously, not because measurement is clumsy, but because the two aspects are genuinely irreducible to each other. This is the same pairing observed in the preceding essay at the scale of atoms, galaxies, and the living body. Heisenberg did not discover a quirk of subatomic physics. He discovered, in the most mathematically precise terms available to him, the same structural fact that anatomy and physiology instantiate in the body, and that Maxwell's equations describe in the electromagnetic field, that organized reality is always and irreducibly both where and when, both structure and process, both located and moving, and that to fully grasp one is always, at some level, to release the other. The hand, examined in the previous essay, has, all the way down to its constituent particles, the same irreducible two-sidedness. There's no level of reality at which the pairing resolves into a single thing. There is no scale at which the structure finally wins over process or process over structure. The pairing goes all the way down and all the way up. This is what the universe is made of. Not things, but pairings. Not objects, but the irreducible relationship between the spatial and the temporal, the structural and the processual, finding its particular expression at every scale, from the quantum event too small to see, to the galaxy too large to hold in one gaze, to the quietly breathing body reading these words. Grateful.